Hello gang, I hope this finds you all well. We are going to start using a new piece of software for Code Robots, primarily because the new syllabus in South Africa expects you to be able to wire stuff up. And it also expects you to do a little bit of 3D design and 3D printing. And there is one piece of software that will cover both of those things for us. And best of all, it's free and you can use it at home. It's called Autodesk Tinkercad. If you're at school with me, I will have sent you a link to a classroom. Please join up and we'll take it from there. If you're at home and you've just stumbled across this on YouTube, welcome. This is what you can follow along with us at home if you like. This is what we're going to do. So when you're presented with, once you've created your account, use your school logins for my pupils, you will find yourself at this page. And the first thing we're going to worry about, there's 3D design at the top, but we're going to look at circuits. So we're creating a new circuit. Circuits. What does that mean? It's quite simple. It's very simple. Simple electronics. Can you see on the top right it says basic here? First of all, make that all. And then all the components that you can use. Look, LEDs, motors. Motors is something we have to cover in the syllabus. Piezoelectric, making a noise. That's a little sounder. We have to cover that. We have to cover solar cells, and we have to cover a couple of other things that are in here, LEDs, motion sensors, all of this. So everything we need to cover in the syllabus can be found here in Tinkercad in simulation. And the great thing about simulation is you can wire stuff up wrong all day long and it doesn't matter. You can just keep going until it works. So let's give you an example. Enough waffle from me as ever. Let's go. Let's pull a battery across. So that's one of those AA batteries, as it says there. You've all seen those. Can you see there's two terminals at the top? A black one and a red one. That's negative and positive. Remember, electrons flow from negative to the positive terminal, and when they go through something happens. Let's find something for it to go through. What have I never used? I've never used it. No, let's have a standard old DC motor. Let's have that. Now, it's all very awkward. You see, it's a good idea to line these terminals up. What you can do up in the top left here is you can rotate the battery in this case, and let's rotate the motor. Oh no, so we got that wrong, didn't we? It's that one there. There we go. Now let's have a look. So yeah, we have negative going to negative, and you can change the color of the wire up there. Good idea to do that. Okay. And positive to positive, because if you have the correct colors on the wires, you'll be able to more easily understand what's going on. Now, nothing's happening. That's dull, isn't it? Oh, that's right, because I've got to press start simulation. So I press that, and around goes the motor, and it tells us it's going on at 2,974 revolutions per minute. My word, that motor's spinning. That is super duper spinning. So that's a circuit. The electrons are moving around, driving the motor, going back into the battery. It's as simple as that. So that's the sort of thing we'll be doing with this. Let's get rid of that. Should have stopped the simulation, I suppose. What else have we got in here that we can just quickly show you very easily? There's a push button. So let's put the button there. And let's not have a motor this time. Let's have a light bulb. Now, let's go. It's going to be a red wire, just because. Oh, I know. Let's rotate this, because that's either side of the switch. So let's rotate it so we can connect it a little bit better. So we go up there, and then we'll take that wire out there and put it over there. Oh, let me show you something else here as well. See, that's made a horribly. Well, it's a horrible straight line, basically. If I do this, if I come down and click, and click, and click, and click, and click, sort of a little bit tidier, isn't it? There we are. So that's a good idea. And then what we're going to do, oh, look, wrong colour, but we'll sort that in a second. Click down, across, and up to make a circuit. Oh, tidy that up, sir. Come on. Right, now get the right colour on there, sir. Make that black. Make this black. There we go. Right, there we are. So that's appropriate. Start simulation. Does anything happen? Nothing happens. Press the button. You see I'll move my mouse over that. Press a button, light comes on. Happy days. So yeah, that's very basically what wiring something in Tinkercad looks like. We will come on to using the BBC microbit controller, which we'll drag into our work. Then we can then use anything from the pins down here, and we can add in our blocks code like that. So that's where we're taking this. This is where the journey's going. But some of the first things we'll have to do is just light a light bulb, turn a motor, do all those sort of things, and then we'll move to some more interesting stuff. So have a play with this. Oh, another thing to tell you. Can you see up there it's given it a crazy name? It'll give your project a random crazy name. You can leave it like that if you want. But if you're going to end up sharing stuff with me, then perhaps we need to to work on naming that appropriately. So that's where you change it up there and just say, make it grown up. Whatever it is. No, that didn't work, did it? Look, let's try it again. Change it. There we are. Okay, it took a while. I see the other one did come there. So that's basically what we're going to be using Tinkercad for to start with, is to run through the electronics part or requirement of the new syllabus in South Africa. It's quite easy. We'll get it done very quickly. And you say, as I say, you can play with this all day long and you won't break it. Thanks for watching. We'll do something interesting next time. Cheers for now. Get logged in. Have a play. Bye-bye.